In this lesson, 3.6, we're looking at the zeros of a quadratic function. When you're done, you will be able to use a variety of strategies to determine the number of zeros of your quadratic function. The first thing we want to look at here is how many ways a parabola can intersect the x-axis. You can see that a parabola drawn here intersects the x-axis in two places, where x equals -5 and at x equals 1. The next parabola intersects the x-axis in only one point, at x equals 5. This final parabola doesn't intersect the x-axis at all. As you can see by these three drawings, there are three different ways that a parabola can intersect the x-axis. So how do we determine which one our parabola is and distinguish between them? The points where the parabola cross the x-axis are the points where y equals 0 and are also known as the x-intercepts of the parabola. We can use the quadratic formula to find the x-intercepts of any given quadratic equation. Looking at the quadratic equation, we define the number under the radical sign, b squared minus 4ac, as something called the discriminant. So the discriminant, capital D, equals b squared minus 4ac. And it is this discriminant that determines how many real roots we can have and the nature of those roots. In other words, it determines how many ways the parabola intersects the x-axis. Let's look at our three cases again. The first case, there are two ways that the parabola can intersect the x-axis. In this case, our discriminant is greater than 0. In the second case, where the parabola intersects the axis in one point, we have two roots, but they're equal. And in this case, the discriminant equals 0. In the third case, the discriminant is going to be less than 0 because there are no real roots. The key to determining the number of ways that a parabola can intersect the x-axis, therefore, is the discriminant. When the discriminant is greater than 0, there are two distinct real roots. When the discriminant equals 0, there are two equal real roots. And when the discriminant is less than 0, there are no real roots. Looking at the quadratic formula, you see why this is so. When the value of the discriminant is greater than 0, we get a real number for our term, and therefore we're adding and subtracting that real number, giving us two values of x. When we have 0 as the discriminant, there's a 0 under the radical sign, and therefore our x becomes simply negative b over 2a. When the discriminant is less than 0, we have the square root of a negative number, which is not possible. It is not a real value. So this is why the discriminant is very important when looking at the number of ways that we can find or that we can solve a quadratic equation. Okay, let's look at some examples now of how we would use the discriminant to solve problems. Remember, the discriminant is defined as b squared minus 4ac when you have your quadratic function in standard form. So let's look at the first one. In this case, a equals 1, b equals -5, and c equals 7. Substituting that into our discriminant equation, b squared minus 4ac, we get that the discriminant equals -5 squared minus 4 times 1 times 7, which ends up being 25 minus 28, or -3. That tells us that there are no real roots because our discriminant is less than 0. In other words, we can't find values to solve this equation. Let's look at the second example. In this case, a equals 2, b equals 4, and c equals -3. Our discriminant is still b squared minus 4ac, which equals 16, which is b squared minus 4 times 2 times -3. which is 16 plus 24, which equals 40. So in this case, our discriminant is greater than 0. So now we know that we have two distinct real roots. Finally, looking at our last example, we have a equals 1, b equals negative 14, and c equals 49. When we find our discriminant, b squared minus 4ac, we have negative 14 squared minus 4 times 1 times 49, which equals 0. So in this case, since our d equals 0, we have one real root, or two same roots. Okay, let's look at an example that might be something you see on an assessment, or a test, or an assignment. Given this equation, we want to solve for x, find the value of the discriminant, and determine how many distinct solutions there are. So as you can see, the discriminant is what we're going to do first. So discriminant is b squared minus 4ac. Substituting in our values, we get discriminant equals 144 minus 144, which is 0. So this tells us that there is one distinct solution. So we have one real root for this equation. Now let's solve. We're going to solve by factoring because this seems quite straightforward. So the first thing we want to do when solving by factoring is look for a common factor, which in this case is 2 or minus 2. So let's say we have 1 equals minus 2 times x squared minus 6x plus 9. Now we can look and we see that that is a perfect square trinomial, which is what we expect having only one answer or one solution. So y equals negative 2x minus 3 squared. Now we can find our zeros. Okay, we set our equation equal to 0 and solve. Because this is a perfect square, we know we're going to only have one answer, and in this case, x minus 3 has to equal 0, or x must equal 3. Proving that we have just one real solution. This time, we're going to solve for x or factor first. So again, we can take out a common factor. So y equals 2x squared plus 6x minus 8. We're going to take out our common factor of 2, leaving us with x squared plus 3x minus 4, which we can see is quite easily factored. We get two numbers that multiply to negative 4 and add to 3, so we have x plus 4 times x minus 1. Then we can solve, because we know that either x plus 4 equals 0, giving us x equals negative 4, or x minus 1 equals 0, giving us x equals 1. Great. So now, what's the value of the discriminant? We know it's going to be greater than 0, but let's figure out what it actually is. Okay, let's just move this out of the way, and we can find our discriminant. D equals b squared minus 4ac equals 6 squared minus 4 times 2 times negative 8, which equals 36, plus 1664, which equals 100. So our discriminant was 100, which is greater than 0. Therefore, we have two real roots, which is what we saw when we solved the equation first. Finally, let's look at our last example. Let's find the discriminant first. B squared minus 4ac gives us minus 4 squared minus 4 times 1 times 7, which gives us 16 minus 28, or negative 12. In this case, our discriminant is less than 0, so there are no real solutions to this problem. That being said, we still need to solve and see what we have for our zeros. In this case, we have y equals x squared minus 4x plus 7. We cannot factor because there are no numbers that multiply to 7 and add to negative 4. So we can use the quadratic formula to solve. Minus b plus or minus b squared minus 4ac all over 2a. In this case, therefore, x equals 4 plus or minus root negative 12 all over 2. And that's as far as we can go because we know that there's no real solution. So in this case, you can solve it, but you need to state quite specifically that there is no real solution to this problem.